All right. Well, happy Monday. It's week 3, and we are moving right along with kind of our introduction to Python. So, just a couple things. I've posted some additional homework, homework exercise, homework. So you'll do those data camp homework. Week 2 has been posted, and then also weeks 3 and 4 have been posted. And then, starting with week 2, and that's due in a couple of days here, the way you'll show that you've completed your data camp is you'll take a screenshot of basically like that you've completed those assignments. You'll take a screenshot of like basically like on data camp, but I think it'll show like completed, or you can take a screenshot of the course outline that will say like you did 100% this chapter or something like that, and then you'll submit that to Canvas there. Also, so I think you guys are aware of ChatGPT, and ChatGPT is super, or all of these AIs, they're super powerful, and they can teach you quite a bit about Python programming or any kind of programming language. So the key here is you want to use it to help you learn, not to do your work for you. Okay, so if you just say like, here's my homework problem, can you give me the answer, that's going to take away your learning opportunity, right? Again, my comparison is always kind of going to, if you go to the gym to like lift weights and you want to get stronger, you have to lift the weights yourself. Now, but you can learn from somebody at the gym, and you can say, hey, can you teach me what's the proper form? Can you help me? And you can learn a lot that way from talking to an experienced person at the gym. But if you say, hey, can you lift this for me? Then you're not going to get any better. So in the same way, you can ask ChatGPT, can you teach me about this? Can you give me examples of this and help me understand what's going on, right? So today's lesson is going to be about dictionaries, and I'm going to show you a few ways to create dictionaries. But you can say you can write something like, I want to learn about dictionaries in Python. Can you show me several examples of creating a dictionary in Python, dictionary in Python in different ways. Okay, so then I'll say, so sure, here's how to do it, right? So creating a dictionary using curly braces. So this is an example here. Using the dict constructor, creating a dictionary from a list of tuples, using a dictionary comprehension, creating a dictionary with default values from keys, using zip, nested dictionary. Okay, so these are it just kind of lists off a bunch of different examples and things like that, right? But again, treat this like you're talking to somebody who is very experienced and knowledgeable, and you can kind of use it as a way to help you like deepen your understanding. So there's, so I'm going to show you like this is how we've created dictionaries, and I think I've got some pretty good examples and whatnot in my lecture notes. But any of these things where you're like, oh, I want to learn a little bit more, you can always kind of take that topic, turn to ChatGPT, and just kind of ask a question. And if you preface it with like, I want to learn more about this, can you show me examples of this? Then I think its examples and responses are quite helpful. And the whole academic world and all of professors and a lot of my colleagues, we're not quite sure how to handle like ChatGPT, because it's really changing a lot. And especially when it comes to like turned in homework, or assignments and essays and things like that, it is creating kind of a problem of like, how much is the student doing themselves versus like how much are they turning to these tools and resources. And so that, it is a little troublesome, but at the same time, it is like such a powerful resource, and I don't want us to miss the opportunity to like use it for good and our betterment. Okay, and so I do think this does present an opportunity to kind of like almost like have your own tutor. All right, so like if you like if you're trying to learn something, you can have a tutor and a personalized tutor, and you can ask questions and use it as a resource to learn from, okay? But again, if you ask your tutor to do your homework for you, right, they might be able to do your homework for you, but you're gonna miss out on the opportunity, right? And so something, an important thing of testing your own knowledge and building your own knowledge and understanding is to kind of do things on your own and for you to think through those solutions on your own. And so, you know, when you are given the homework problems and things like that, please do try to do them yourself rather than kind of asking the AI to do the solution for you. But as far as asking it for additional examples, asking it to help you understand certain things, I think it's pretty great. Okay. All right. So anyway. You know, and you can also just ask questions kind of like, you know, when would it be better to use a list than a dictionary in Python, okay? Right? It always puts in this fluff here. Great question, okay? When to use a list, ordered data, sequential data would do in, let's see. You know, essential data, but they serve different purposes. Here's some considerations and things like that. Okay, so use a list here. So it kind of gives you, well, these are all lists. This is not very great. Okay, dictionaries will always be key value pairs. All right, well, anyway. All right, it's still going with its response here. But anyway, you can ask these questions, and it's you know, it might give you a super long response, but a lot of answers will be handy. Okay, but anyway, let's talk about dictionaries. So again, last week we talked about lists, and lists will kind of contain all of these values. They are ordered. And you can have values of different types and things like that, okay? The key difference here with a dictionary, okay, is you get a structure a data structure where you can hold different values in there, okay? But the key difference is that with lists, items are accessed by position. So you'd say, hey, give me the 5th item in the list, okay? Give me the index 7 position, give me the index 0 position in the list. Whereas dictionaries, all of the values are associated with keys, okay? So you'd say, give me the value associated with, this particular key, okay? So so when we create a dictionary, kind of the most common way as far as like creating it directly is you use these curly braces, okay? Lists use square braces or square brackets, and dictionaries use curly braces, and then you use a colon to separate the key from the value. So here, I'm going to create a key Adam, and the value is going to be 25. Key Bob, value is 19. Key Carl, the value is 30. So you could think of this as like, you know, people ABC, maybe there's their ages and years, I don't know, all right? So this is what we have. When you ask, print out, actually not just print it, but you just say, hey, what does the dictionary look like? This is what the dictionary looks like, okay? So in Python, to know if you see curly braces, you know it's a dictionary, okay? Well, curly braces and colons inside. If generally you put strings, well, I guess if your keys are strings, you would put them in quotes, but you can use integers. Any kind of hashable value can be a key here. But in some cases, you can just create a dictionary, and you can you don't even have to put quotes around them if you're going to use something like this. So you can call the function dict, okay? And this is what we call the dictionary constructor. And we could say, hey, Adam equal to 25, Bob equal 19, Carl equal 30, and Python will kind of interpret this and create the appropriate dictionary, okay? So again, the general way we would do this is we have the key colon the value, but again, there's different ways you can kind of create a dictionary, okay? Another way you can create a dictionary is with something called a zip object, okay? What a zip object is, it takes two iterables and it zips them together, okay? So you imagine kind of a zipper where it takes, one, you've got the kind of the teeth on each side, and it matches, each kind of tooth or each item in these iterables together. So here I have two lists, okay? But it could be, any kind of iterable, like a tuple or whatever. But I'm gonna create a zip structure, okay? So I take, and what this is gonna do is it's gonna zip Adam with the first value, Adam, with the first value over here, 25. It's gonna zip the second value, Bob, with the second value, 19. And it's gonna zip Carl, the third value, with the third value, 30 over here, okay? Now again, Python is lazy, so when you tell it to zip these two data structures together, these two lists, it'll say, okay, I know it, this is what you want me to do, but it's not actually going to do it until it has to, okay? So if you just say, hey, what is that thing you just made? It says, yeah, you told me to zip these things together. So I've got a zip object coming along, but and I'll just tell you what they are. What values get matched to what values when you need me to, right? It's kind of like if I gave you a stack of papers and I say I need you to collate these together, you could say, okay, I can do that, but you don't actually want to do it, right? Until I like say, okay, I need the 50th thing in the stack, and you can be like, okay, I'm gonna get to it and then get you the 50th thing. But if I give you like a giant stack of like 1,000 papers and 1,000 papers, it's actually a lot of work to try to collate everything together, and that's basically what a zip does. And Python is, again, inherently it's lazy in that, and again, it's not a bad thing. It's saving your computer from doing unnecessary calculations that it doesn't need to. Okay, but here if you say, all right, I want you to make a dictionary out of this zip, okay, then Python will say, okay, I will go ahead and match everything up and I will make a dictionary out of it. And you can see it has taken Adam and matched it with 25, and Bob matched it with 19, and Carl matched it with 30, and it has created a dictionary out of these things. Okay, actually here, let me clear everything out, and let's run these. Connecting to the terminal. Okay. All right, so there it is. Okay. This is inside the function dict, okay, I have put in a list of tuples, okay? So I've got a list length 3, and within that list I have a tuple which consists of the key and the value pair, okay? So I've got the name Adam, along with the value 25. So I've got a tuple here, and then I've got Bob and 19 and Carl and 30, and I say, hey, make a dictionary out of this, and it makes a dictionary out of that, and there you go. Okay, so all of these, you kind of put them into the dictionary constructor, and Python, depending on what you give it, this dictionary constructor is smart enough to kind of understand these different forms and what it's expected to do. Okay. So you can kind of do these things, and where it says, okay, this is what you want me to do, and I'm going to kind of create these things. Okay, so once you have a dictionary created, the way you go about using it is you use the key to access the value, right? So again, here is the dictionary. If I ask, what is people? Okay, this is the dictionary. And we can say, all right, give me the value associated with the key Bob, all right? And it comes back and it says, it's the value 19. And you see, just do people, square bracket, Bob, the key, and it gives you back the associated value, right? So it's kind of like subsetting a list, but in a list you put in an index, integer position for the index, and it will give you the value in that thing. And here with a dictionary, you give it the key, and it gives you the value associated with that key. Okay. There's another function, a method called .get. You give it the name of the dictionary, you do .get, and then you put the name of the key, and it gives you the value. Okay. Why do we have two of these things? The difference is that if you do square bracket and you give it a key that doesn't exist, okay, people, and you do square bracket Joe is not a key in my dictionary, this is going to raise an error. This raises an exception, and you get what's called a key error. It says, hey, this key doesn't exist. This is a key error, all right? On the other hand, if you call .get and you give it something that doesn't exist, it returns none, okay? Now remember, here, generally, if you, if I didn't call print on this, right, then it like returns, like the literal returning none, like nothing gets output to the screen. So in order to kind of show you that it returns none, I called print on this, but people.get, or dictionary.get, and you give it a key that doesn't exist, then you get nothing back. Okay. If you want, you can give it a default value. So like if it doesn't find Joe, you can say people.get and then comma and then the default value for if it can't find it, and so here now it will return 0. Okay. So that would be the big difference between using the .get method versus doing square bracket. Probably more common, like as you read other people's code and things like that, probably more common is to use the square bracket and the key, and that's probably the most common way to get access values from a dictionary. But again, just be aware that if you give it a key that doesn't exist, you're going to get an error. Okay. As far as the keys can be any what we call immutable object. Okay, so these are objects like strings, numbers, tuples, even functions. Okay, so these are things that can't be altered. They are, once they're created, they are set. Okay, dictionaries are not allowed to have duplicate keys. Okay, and as far as values go, there's no restriction on what a dictionary value can be. So dictionary values can be any other type of object, including lists, tuples, other dictionaries, functions, things like that. Okay, so here I'm creating a dictionary. The first key is 1, and the value is going to be the function length, okay, the len function. The next key is the integer 3, and I'm providing as its value a dictionary with key first and value A. Okay. The next value key is 4, and I'm creating the value is a tuple 1, 2, and then the final key is the number 2, and the value is this list 20, 4, and 5. Okay. So that's going to be the dictionary. I can say, all right, give me back the value associated with key 1. Okay. So then I get the function length. Okay, give me the value associated with key 2, right? And I get the list 24 and 5. Give me the value associated with key 3, and I get this list, or in the dictionary. Then give me the value associated with key 4, and I get this thing, right? And then, so here, if I take the second thing, I get this thing. I can do stuff like, okay. I can, because it's a list, I can call list methods like .append, okay? And now if I ask what is the dictionary, you can see that object has been modified, okay? Because that is, that's what you can do with list objects there, okay? All right. So again, anything that is immutable can be, oh, here, before I forget. Your first view quiz answer today is the letter A. A as an apple. A as an apple is your first view quiz answer. Okay, the keys in a dictionary have to be what we call immutable or hashable, okay? Only immutable objects are hashable. And so things like a list is mutable, meaning like you can take the list and modify it, so it cannot be used as a key. So here I've got an object L, which is going to be a list, square bracket 1, 2, and I've got an object T, which is a tuple, and the tuple is parentheses, 1, 2, okay? So here I'm going to create an empty dictionary. D is this empty dictionary, and if I try to create a new entry in the dictionary by using assignment and the key value, I can do D key value L and set it equal to won't work. This is going to cause a problem, right? It's going to say unhashable type. This is a type error. The thing here, this L that we're giving it is a list, and we can't hash it, so it raises an error, okay? Whereas the tuple over here, this is hashable, okay? And it allows me to create the dictionary here. So if I ask what is D, then the tuple 1, 2 is the key, and that's okay, right? Okay. If you try to Python does not allow a dictionary to have duplicate keys. Okay, so that's a key thing. If you kind of like try to create a dictionary where you're like using the same key multiple times, Python just reads left to right, and basically as it encounters the same key again, it just updates the value. Okay, updates the value associated with that key. So here, when I start the dictionary creation, I say, you know, the key A gets the value 1, the key B gets the value 10, and then it reads left to right, and it says, oh, you know what, update the key A to the value 2, update the key B to the value 3, update the key A to the value 3, okay? Or update the, what did it say? B to 0 and A to 3. So at the end of the day, you have a dictionary, and you're going to have key A with the value 3 and key B with the value 0, because it just reads left to right. And as it encounters the same key again, it's not going to create a duplicate entry. It's just going to update the value associated with that key. Okay? So if I say, hey, what is the value with B? You get 0. What is the value associated with A? You get the value 3. One thing that's really important is dictionaries are not indexed by position, okay? So you can't use numeric indexes. If you provide a number, that number needs to be a key in the dictionary. So if I try to say, hey, give me the 0 value here, okay? With a list, this would give you the first entry, okay? The index 0 position is this what you would get here. But people is not a list, it's a dictionary, so it's going to say, hey, what is the value associated with the key 0? And this is going to cause an error because there's no key 0. Okay, you're going to get a key error. Basically, anytime you see key error with a dictionary, that means that key doesn't exist in the dictionary. So we don't have the key 0. Okay. Dictionaries cannot be sliced because slices depend on position. So if you try to say, hey, I want everything from position 0 to position 2, okay, that's not going to work, okay, because you can't slice a dictionary. And you might say, well, what if I want to get the values from Adam to Carl, okay? Also, not going to work, okay, because you can't slice a dictionary, right? So you might be like, well, okay, what if I, you know, it's not going to work. It's not going to work, okay? With the dictionary, you do have a couple operators, okay? So we have this operator in, all right? And this applies to the keys, not the values, okay? But the keys. So you can say, hey, is Adam a key in the dictionary people, okay? And that's going to come back as true because in the dictionary people, we have Adam, Bob, and Carl as keys, and the values are, whatever, 25, 19, and 30. Now, if you ask, hey, is 19 in people, okay, it's checking for 19 as one of the keys. 19 is not one of the keys, so 19 in people comes back false, okay? If you want to check if it's one of the values, you can do 19 in people.values, okay? 19 in people.values is going to come back as true. All right, now this is getting a little bit, a little more CSE, but the in operator works differently for lists and dictionaries, okay? So if you have a list, and because you can use, is 19 a value in your list? And what Python does is it starts at the beginning and it goes through the list and it basically checks to see if 19 matches any of the values in the list. And if it does, it'll come back and say, yes, we found a match. Or it gets to the end of the list and it says, nope, we didn't find a match. Okay, it comes back false. The thing about using the in operator with a list is that if your list is really long, like if you've got 1 million entries in your list, then that in operator takes a long time because it's going through the entire list, okay? It's just kind of like, if you were, working at some kind of, if you were the bouncer at a party and you have to check the guest list, right? And you have to go through every single thing. It would take a long time if you have a very long list of guests who are invited, okay? Whereas with the dictionary, it almost feels like magic, okay? But the keys have what's called uses something called a hash table, and somehow when you say, hey, Python, is this key in the dictionary? It's able to give you an answer like immediately without having to check every single answer. And it's almost it's hard to explain the actual like logic and the algorithm going behind it, but just know that even if you have like 1 million entries or 1,000 entries or 1 billion entries in your dictionary, okay, there's basically additional information associated with the dictionary where you can kind of just check to see if a value is one of the keys, and instantly you will get a response back, okay? And so in some cases, even if you don't have, like you might want to use a dictionary, even if you don't have like keys and values, right? Like dictionaries, you always have keys and values, but in some cases, you don't even have values that you care about, but you just have a whole bunch of entries, and you can just make those keys. All of the values could be 0, but you'll get the advantage of having this kind of hashable lookup, right? And that's actually in your next homework, you'll be using that with, or is it maybe the following homework? I don't know. You have like this big list of words. And if you just create a traditional list with the words, it takes a long time to kind of find your entries. But if you use a dictionary and you use the words as all of the keys inside the dictionary, you get this kind of instantaneous lookup advantage there. All right, let's keep talking about working with this dictionary. All right, so here's my dictionary people. I've got Adam, Bob, and Carl. If you want to add a new entry, you can just create a new entry just like this. You use assignment, okay? And you give it a new key. So here's Derek, gets the value 33. We're going to throw in Adam, and we're going to update the value to 26, okay? And so now my dictionary has Derek and Adam has been updated. Okay, so that's simple enough. If you want to delete a dictionary, you call delete. Okay, so here's people. You say delete del. All right, and then so we're going to get rid of Carl, and Carl is gone. Okay. You have methods. There's a pop method. Okay, pop will basically just remove that thing and return the value. So here, I'm going to call people.pop, and we're going to pop Adam, and that will return the value associated with Adam, which is 26. And then when we ask for what does people look like, it no longer contains Adam because Adam has been removed. So we've removed Adam from the thing. We popped Adam, but then we have returned his value. Okay. Now, when you call pop, you have to supply a key. You have to supply a key. Okay. Because again, dictionaries are unordered, and so there's no, with a list, and you say pop, and you don't provide an argument, it's going to pop the last entry in the list. But a dictionary, there's no like first or last. Okay. So we have that. Okay. Sometimes you want to like add additional things, additional keys to your thing, right? So here I've got people A, I've got Adam, Bob, Carl, ABC. I've got people B, I've got Dave, Earl, Fred. Okay. Okay. And you don't, you can't just plus a dictionary together. Right? With a list, you can kind of plus and it will like concatenate them together. But because dictionaries can't have duplicate entries, you need a way to kind of like if I had two dictionaries and they had like duplicate entries and I tried to do a plus together, there's some confusion as what should happen. So what you do is you call, you use update, okay? And you say people, dictionary A, people A, update with dictionary B, people B. And what that will do is it will tell Python that like if you do encounter duplicates, use the values in people B, the second dictionary, to update all the values in the first dictionary, all right? And that avoids any kind of confusion here. So now we say, okay, well, what does people A look like? Because we've taken the people A dictionary and we've updated it with the entries in people B. And so now we have, A, B, C, D, E, F, Adam, Bob, Carl, Dave, Earl, Fred. And we have that, okay? So now here is, again, dictionary A, people A, and then I've got another dictionary, Fred and Gary. Okay, so Fred's a duplicate. And here if I say, take people A and update it with people C, okay, now this thing with Fred, his value is going to get updated to 99, and we have that, okay? And then just now that we've got this many entries, or this length, Python prints it vertically, but it's the same format, okay? A, B, C, D, E, F, G now, okay? All right, let me give you your next answer. Next answer is E. E as in elephant. E as in elephant. All right, dictionaries support what's called a view object. These are dynamic view objects, and these dynamic view objects update automatically when the associated dictionary gets updated, okay? So here I've created a dictionary called people, and it's got keys ABC, or Adam, Bob, Carl. The value is 25, 19, and 30. So I can create a view object called people.keys and a view object of the values, all right? And it will be ages. So here I've got names, and it'll say dictionary keys, Adam, Bob, Carl. I can say ages, dictionary values 25, 19, 30. Okay, so notice what's going to happen here. I'm going to create a new entry in the people dictionary. We're going to put ed 40. Okay? And without redefining what names is, okay? If I ask what is names now, this view object automatically gets updated. Okay? So now we have Adam, Bob, Carl, and ed. Okay? So without saying like ed is the entries in, the keys in the dictionary, it just gets updated. As the dictionary gets updated, the view object also gets updated. Okay, ages also gets updated, right? And that's about it. Now, as far as the view objects, there's not a ton you can do with it, okay? You can check the length, okay? You can say the length of ages, and so this will get updated as you add more entries in it, okay? It'll update, okay? Is 35 a value in the ages? It's not, so that comes back as false. So you can check the length and you can check for in. Now, if you need to do more, with the thing, you can convert the view object to a list. But once you do that, it is no longer a view object. Okay, it's no longer associated with the dictionary and does not dynamically update. So here I can say, hey, take ages and make a list out of it. Okay, and if I do that, then this looks like a list. Okay, and I can do whatever I need to do with a list and things like that. Okay, but it's going to lose the dynamic power. So if I say, hey, I'm going to create a new entry in the people dictionary. Okay, so we're going to create an entry key Frank with the value 29. The ages object, which is a view object, that gets updated. Okay, 29 is now a new value inside the ages object. Okay, however, this age list that we created back here, that does not get updated, right? So this is static. This is just at this instance when we created the list, that's all it's going to be. Okay, whereas the values, the view object is dynamic and gets updated. Okay, however, with ages, because it's a view object, you're not able to ask questions like, hey, what is the third entry in it? Okay, you can't even ask like, hey, what is the value associated with Bob? You need to go straight to the dictionary for that. Okay, but with the list, you can ask, hey, what is the third entry? Index 3 position, which will be 40, and so on and so forth. Okay. There's another view object, and this is .items. Okay. And .items looks kind of like a list of tuples, okay? So the items associates each of the keys with the values. So dictionary.items, you have kind of, again, it's a view object, so it dynamically updates, okay? But you get a view object containing tuples, or things that look like tuples of key value pairs. Okay, so you have Adam 25, Bob 19, Carl 30, so on and so forth. Okay, again, I could create a list out of this, and now I'm going to get a list of tuples. Okay, so if I create this, then I'll get a list of tuples, and I can work with this. Again, the .items is a view object, so you're limited to what you can do, but it will be a dynamically updated view object. So you can, with dictionary.items, you can do something like, is Adam 25 in dict items, and that, what is it called? Oh, dict items. Okay, so that's going to come back as true, right? So you can say, hey, is this tuple inside there? And you can kind of check, is that one in there? That one doesn't match. But and things like that. Okay. All right, let's just kind of look at a couple examples of dictionaries. So dictionaries are one of the things that Python does really, really, really well. Okay, as far as the data structure goes, it's probably one of Python's most powerful data structures, and there's so much you can do with it. And a lot of kind of Python packages and functions and things like that are powered by dictionaries. So it will do you very well to understand dictionaries. I'm going to just show you a couple examples of some of the things you can do with dictionaries. But again, this is just scratching the surface because this idea of having a key and a value associated with it and having these keys, hashable and everything, there's a ton you can do, okay? So just a silly example, let's say you have a string and you just want to count how many times each letter appears, okay? There's a ton of ways you can do this. One is you could just say you can have 26 different variables, a variable for A, a variable for B, a variable for C, and you can have each of these things count how many times that letter appears, okay? Another is you can create a list of length 26. the first entry is how many times A appears, the next entry is how many times B appears, so on and so forth, until the last entry in the list is how many times Z appears, okay? Or lastly, I mean, again, not lastly, but like another way you could do it is you could have a dictionary, and you have keys A, B, C, D, E up through Z, and then each value associated with that key is going to be how many times that letter appears, okay? And so we'll try the dictionary approach, okay? And so what we're going to do is we're going to create this function called histogram. I mean, this is like, I guess, a character histogram or letter histogram. And what this will do is it's going to return a dictionary where how many times each letter appears. And what we're going to do is we're going to take whatever string gets supplied, and we're going to iterate through it. We're going to go through each character in that string, okay? Because again, a string is an iterable. We're going to look at each character in it, and we're going to first ask, is the character a key in the dictionary? Okay? And if it's not a key in the dictionary, so if the character is not in D, then let's create an entry in the dictionary. We're going to say D for that character. We're going to set it equal to 1. So that will be kind of the starting one, okay? On the other hand, if the character is already an entry in the dictionary, then add 1 to whatever that value is, okay? And just go through the entire string. Once it's done, return whatever dictionary we get. So here we go. We'll create here's a string, abracadabra, okay? And so it's going to start off with A. The very first time, it's going to say, like, A doesn't appear. We're going to put a 1 in. And then as it goes through, when it encounters A multiple times, it's going to say, oh, we have a total of A 5 times in here, right? So in abracadabra, A shows up 5 times, B shows up twice, R shows up twice, C shows up once, D shows up once, okay? And so there you get the dictionary there, right? Whoops. You can do a histogram on she sells seashells by the seashore, okay? And we get S appears 8 times, H4, E7, space 5, L4, you know, so on and so forth, okay? It goes through and it iterates each of these letters here. Once you have a dictionary, okay, you can kind of iterate over them, okay? So you can do kind of for every key in the dictionary, you can print the key and then the value associated with the key, right? So remember, H is this histogram for abracadabra. So when we go for H, for key in the H, it's just going to go through, and it's going to kind of go through the 5 entries in this dictionary, A, B, R, C, and D. Okay. You can also kind of take the dictionary, and you can call it sorted, and it will take the dictionary and sort based on the key. So here's the dictionary. I can take sorted on H, and again, that's going to return the keys, okay? The keys of the dictionary in sorted order, okay? So here we're going to say for key in sorted H, go ahead and print the key along with the value associated with each key there, okay? And we have that. All of the dictionaries are designed to return a value when you provide the key, but sometimes you want to find the key associated with a particular value, okay? And this is kind of a lot trickier, and so this here I'm going to create a function to kind of help us with this. And this is going to be, we're going to call this reverse lookup, and we're going to find, we're going to supply a dictionary, and we're going to try to find the values associated, we're going to find the key associated with the value, say 2, all right? So here's my dictionary. If I provide a dictionary with A5, B2, C1, D1, and R2, I can, what I'm going to do is I'm going to basically go through every entry in the dictionary, and we're going to say if the value associated with that key is the value I provided, then return that key. Okay, so this will just kind of return the first value, the first key that matches that value. And if it reaches all the way at the end, we're going to raise an error called a lookup error. Okay, And so here's my dictionary H, and we can say, hey, look up H2, and it gives us the first entry where it matches the 2, and it gives me back a 5. And it gives me back B, okay? It says the first key that produced a value of 2 is B. If we try to say, hey, look up, give me a key that is associated with the value 4, we're going to get an error, okay? This is raise statement, okay? So this raise statement is how Python handles errors. So if, as you write functions where you suspect, you could run into a problem where, it's not going to be able to find something, you want to put in a little bit of exception handling, right? And so raise is one way for us to do this. And there's all kinds of different errors, okay, that you can get. And so you can look up the different kinds of exceptions. And so these are some of the built-in exceptions, and you can have, lookup errors. And so this is like, again, you can name how you want to do it, right? Key error, name error, memory error, not implemented error, so on and so forth. These are the different kinds of errors. Now, Python does a good job of properly raising the correct kind of error. But when you write your own functions, you can intentionally raise the wrong type of error. It will be very confusing to the user. But there's nothing inherent about saying like if I didn't call this a lookup error and I called it raise value error, okay? Then it will raise a value error here, okay? Now that would be, I think it would be kind of confusing to the user for something like that, okay? But again, all of these things are designed so that people who use your scripts, which will generally be you, okay, can understand what went wrong. And so you want to kind of imagine like you're trying to send yourself messages to yourself in the future, right? So that like when you read your own code and use your own code in the future and you encounter messages or encounter errors, like you can understand what went wrong. So it's a little bit hard to think about future self, but future self is going to rely on past self, and you want to do a good job, okay? Do you ever like daydream about like going back in time and talking to past self and giving them advice? So basically you want to do as good of a job now so that future self doesn't have any regrets and say, all right, I would go back in time and fix this thing. Okay. You can have lists as values themselves in the dictionaries, right? So dictionaries, you can't have lists as the keys, but lists can be the values. And so, one thing about this lookup thing is like, what if I wanted to find all of the keys associated with the value 2, right? This one just gives me back the first key associated with the value 2, but what if I want all of the keys associated with the value 2, okay? So here I'm going to create what's called an inverted dictionary. And so the inverted dictionary is going to take existing dictionary, and then it's going to basically swap all of the keys and the values, but then if some of the values appear more than once, then we're going to create an entry, a dictionary entry with multiple entries in it. So like, for example, in this histogram, or in this thing where I've got A5, B2, R2, C1, and D1, I want to switch these around so that my keys will be 1, 2, and 5, but then associated with the key 1, I want C and D, and associated with the key 2, I want B and R. That's what I want to do, okay? Rather than just saying, hey, give me, so when I say, hey, give me what's associated with 2, rather than just saying B, I want to get B and R back. So that's what we're going to try to do here. So we're going to create an inverted dictionary. So I'm going to start off with an empty dictionary. we're going to go through the original dictionary D. We're going to go through each key there, right? The value is going to take, whatever D, whatever value is associated with that key. We're going to take that, and then we're going to check, is that value one of the keys in the inverse? And if it's not, then we will create a new entry in that inverted dictionary, okay? And if it already does exist, then we will take that value and then append it, okay? And then we'll return this entire thing. Okay, so here I've got H. I'm going to take parrot, P-A-R-R-O-T, and then so I have P and A. P appears once, A appears once, R appears twice, O and T appears once. And if I invert that, then for 1 I will get P, A, O, and T, and R I get 2. If I try it with, say, abracadabra, okay? Here is this, A 5, B twice, R twice, C once, D once. We're going to try inverting that, and then we'll get 5 is associated with A, 2 gets associated with B and R, 1 is associated with C and D. Okay, I've gone over my time, so we will end here.